We're going to look at the last part of our functional with multiple independent functions. We're going to look at finding the conjugate points. Now we've seen how to find the x-coordinate of a conjugate point analytically for a simple functional. So the simple functional was of the form f of our independent variable x, y, y dash. And this was this function here, which we've used in some of the previous videos. Now this equation here we've used some of the previous videos. Now what we want to do is extend this to a functional, and we're going to do it to a functional of only two independent functions. Now we know that the solution to the simple functional that we have up here is of this general format here. So we'll have the q is equal to phi of the independent variable t, and we're going to have our two parameters a1 and a2. Again, we've seen that in the previous course, and we've also seen it in parts of this course as well. Now if we extend this idea to a functional with two independent functions, then we'll find that the solution is going to be of this general form here. We're going to have a q1, which is some function phi1 of our independent variable t, and we'll have our four parameters a1 to a4. And again, we're going to have a q2, which is a function phi2 of our independent variable t, and we'll have our parameters a1 to a4. Then if we know the value t0, then we can extend this function here, this solution method that we have above here, such that we can find the conjugate points, if we call the conjugate points t0 dash, and we're going to do that as follows. Now this is just going to be stated, we're not going to prove this. So by extension, the equation that allows us to find the x-coordinates of the conjugate points for a functional with two independent functions is of this form here. Now I'm not going to read it out, I'm not going to prove it here, it's just stated. Now if you're interested in a proof, the proof of this can be found in a book called Calculus of Variations by Andrew Russell Forsyth on page 223. Now I may go ahead with this proof later on in the appendix section of the book which I'll produce for this course, so keep your eye open for that. Now if we were to extend this to not two independent variables but n independent variables, then we're going to have yet another equation here. Now that equation again can be found in this same book in page 267 to 270, and again I may go through that equation and the proof of it in the appendix section of the book for this course. Now we can see how awkward, difficult and contrived the mathematics is becoming. What if we were to extend this up to the third variation or the fourth or the fifth variation? Imagine how difficult and complex the mathematics becomes. I am reminded of a quote by a famous mathematician, John von Neumann. I never quite understood or grasped the significance of this quote until I got into the difficulties and the vagaries of calculus of variations at higher orders. So here's John von Neumann here, and this is the quote which I think is now quite apt. As a mathematical discipline travels far from its empirical source, or still more, if it is a second and third generation only, indirectly inspired from ideas coming from reality, it is beset with very grave dangers. It becomes more and more purely aestheticizing, more and more purely l'art pour l'art, that is, art for art's sake. This need not be bad if the field is surrounded by correlated subjects, which still have a closer empirical connection, or if the discipline is under the influence of men with an exceptionally well-developed taste. but there is a grave danger that the subject will develop along the line of least resistance, that the stream so far from its source will separate into a multitude of insignificant branches, and that the discipline will become a disorganised mass of details and complexities. In other words, at a great distance from its empirical source, or after much abstract inbreeding, a mathematical subject is in danger of degeneration. At inception, the style is usually classical. When it shows signs of becoming baroque, the danger signal is up. It would be easy to give examples, to trace specific evolutions into the baroque and the very high baroque, but this would be too technical. In any event, whenever this stage is reached, the only remedy seems to me to be the rejuvenating return to the source, the re-injection of more or less directly empirical ideas. I am convinced that this is a necessary condition to conserve the freshness and the vitality of the subject, and that this will remain so in the future. If we start to look at the third, the fourth, the fifth variations and higher variations, I think you can agree that the mathematics will become very complicated. And in fact, we would be travelling down the tributaries further and further away from the empirical source. So I think that this quote here aptly describes the direction the mathematics would take if we headed further and further down along this route. So that's all we're going to cover for this type of extension to the functional. We'll go ahead in the next video and we'll look at our second extension to the simple functional. So thank you for listening. I'll get you on the next video. Goodbye.